Hi, I'm Alea Ward,
I'm Noah Andrade.
And I'm Danny Sagenza.
and we are Operatio Plastic.
Our problem and solution. The problem we currently have and we're trying to solve is how to recycle plastic bags. So far, plastic bags aren't really recycled because they get stuck in the gears of machines that recycle plastic. Even though they are made of recyclable material, they aren't being recycled. Our solution to this is to create a machine that uses heat and compression modules that have the capabilities to mold and shape plastic bags into a recyclable shape that can be used for everyday life, whether it be filament for 3D printers or any other household items. First ideas. At the beginning, all three of us, we had three very different ideas developing a machine that would be able to mold the plastic bags. On the left side is my idea, on the middle is Noah's, and on the right is Alea's. Something that we all had in common when brainstorming was the thought of using some sort of contraption to have heating within the contraption and have some sort of pressure applied to it so you can be able to mold the plastic. Learning plans. I decided I would test how hot our containers would be able to get and what we could use to get to the temperatures. On the left hand side, you can see three different items that I used throughout the many different items that we had to try to figure out the correct temperature or to see how high we could get. Alea chose that she would test heat as well, learning how the plastics would melt and what the after effects would be. And Noah determined that he would learn 3D CAD in order to be able to laser cut and 3D print any parts we would need for the machine.
My learning plan was, like Danny said, on shape. And basically, I was trying to learn anything, any 3D CAD skills that we might need to laser cut or to just 3D model a shape that we might want to use into our invention. So on the left hand, you see this penguin, which was just me experimenting with new things, trying to see what I could do. And it was just an experimentation to make sure that I was learning the skills that I might need. In the middle is a sketch. This is when I was learning sketching, just to be able to sketch whatever it is we might need. And on the right is a part that I made that I 3D modeled on Onshape, a part that we could or could not use.
Heat testing. After researching what temperatures we needed to melt plastic and attempting to heat those temperatures, we realized that we needed different heating sources. On the bottom left-hand side, I used a heat lamp to try to figure out the temperature that the crate above it would reach to. And on the right-hand side, I used a little balloon canister to try to figure out what the internal temperature of it would be to see if it would melt the plastic or not.
Figuring out the problem. So throughout all of our experiments, we noticed that there was multiple problems in heating up the plastic and compressing. So at first we thought it was just our invention that it was not working. Turns out it was the fume hood. The fume hood wouldn't let us max out, would continuously make us max out at 47 degrees Celsius. Although in other areas we would see that it would exceed 100 degrees Celsius. So we started to wonder if our invention was truly the problem or if it was the fume hood. Turns out it was multiple things adding on to it. Our first problem was voltage sources. The voltage outlets were not producing enough voltage throughout so that we could get enough heat to generate. And our second problem was the air within the fume hood. There was this knob to turn on air so that fresh air would come in, and that was the problem that was making us max out at 47 degrees Celsius when it could exceed 100 degrees Celsius. So we had actually experimented with this, and we found out that as soon as the air stopped being a problem, we solved the solutions with the voltage outlets. We realized that it could exceed 100 degrees Celsius, and as you can see in this graph, it went up to it reached to 139 degrees Celsius, and it could have gone up if we had left it on for more time. Seeing these temperatures, we realized that it could really melt, and we started to decide that we were going to test it with plastic. After many attempts with no avail, we saw hope when we tried one of our attempts where this plastic started a bubble and parts of it were melted. The reason it started a bubble seemed to be because of the circle within the box, and it seemed that the heat was concentrated in that area, so it started a bubble on only heat within that area. But this was still hope for us that we would be able to melt and compress the plastic.
Our new attempts. Our new attempt consists of compressing the plastic once again. On top of that, also melting it. In order to melt it, we use a film plate from a toaster that Danny had took apart, which conducted heat. In order to conduct that heat, we added 16 voltage DC together on top and bottom with that, which Noah will get into more later. As you can see in the picture, we have how it looked when it was compressed. The circles in it are from the shape of the container that it was in, but that showed how the shape and how the melting impacted it. So we still consider this a huge success, and this would be our second success that we encountered. Our final run was our biggest success, and we are very proud of ourselves. In total, it took about 415 minutes to melt and compress it together. In order to compress it, as you see in the picture, we use metal materials, which were provided us by our teacher, Mr. Stemple, our engineering teacher, Mr. Stemple. In order to get this to melt properly, we had to get it up to 100 degrees, up to 111 degrees. We constantly checked on it. We constantly monitored it in order for it not to overheat, in order for it to not to melt through, start burning or fire anything. We had made the temperature go up. Also, since we were using a fume hood, we turned the fume hood air on so that it can go back down, so that the heat and temperature can stay at a good place, so that the melting can be as successful as possible.
Here we have our before and after. On the left hand is the plastic when we first wrapped it around into a small cube-like shape, so we could fit it into the box that was a square. And that was how it looked like before. Danny had actually wrapped it up. And this was what it looked like after. Once we melted it, we see that it was clearly compressed. It became so much more smaller, and multiple parts of it were melted. And you could even see some bubbles there.
Inside look. So we decided to cut open our final model, in a sense, to see what exactly it would look like on the inside. And before we actually melted it, I accidentally made a mistake of wrapping it with two different plastic films. But it actually turned out to be quite interesting because, as you can see, there was a little design left in between the two plastics. So that also leads to the conclusion that with melting these, you could also come up with different intricate designs that you could use for just a little aesthetic or something interesting that you could have as you melt the plastics.
I also want to add on to the fact that since we have an inside look of the melted plastic, you can see how well it compressed together versus how it started out. Starting out, as Noah pointed out earlier, it was some air bubbles in between it, and that just shows that as we were melting it, it still continued to have air in it. But versus on the inside, you can see that it's nice, compact, and compressed, and there's no signs of air pockets in it whatsoever. As I was stating earlier, here we have our 5 power boxes, each with 12 voltages, which adds up to 60 volts DC. The reason we didn't do AC is because we were not in a safe environment to do it. We kind of want to keep our school for future seniors, incoming seniors. But as you see, our setup includes 2 toaster plates, which on the inside, on the bottom of it, it has conductors, which allows it to heat up. Originally, we did not have 5 power boxes; we had 4, but because of the problems that we continuously ran into, we had to increase it to 60. On top of that, we also only originally had 1 toaster plate. Adding another toaster plate increased the amount of heat that we was able to get from it, and it helped our project out a lot.
Like Ale was saying, we also added the rubber mat to keep it from burning anything. The griddle was there also to just hold in place everything, our whole experiment. And below the rubber mat was 2 iron bars that we had to prevent any bubbles from forming or anything. And yes, we did have to switch from 4 boxes to 5 boxes. We went up from 48 volts to 60 volts just so we can generate more heat so we can melt down the plastic. Here's our acknowledgements. Here's our acknowledgements.
Yeah, I'm sorry. But okay, I'm sorry. So we didn't add this to it, but we want to, before anything, we want to thank the school as well. And because like without the school, we wouldn't be able to do this. We also want to thank you guys for taking the time out to judge our projects. And even though you guys are judging it, we're still going to use this as a learning experience for future experiments that we possibly may do or encounter. And we just want to thank you beforehand for taking the time out and do this.
Yeah. Most importantly, we would like to thank our teacher, Mr. Stemple. He helped us a lot throughout the whole experiments, everything. He really helped us. He really pushed us to do things, and without him, I don't think that we could have really gotten to where we got in because he really helped us. Like he helped us a lot. He helped us with the experience, and he's the reason why we kept hope that it would all work out and we would be able to make a successful project. We would also like to thank our sponsor who provided us with ideas from the beginning and even provided us with that red plastic film you see that we had melted down.
Yeah, so thank you guys. We really appreciate it.
Yeah,
and
thank
hope
you.
That this project catches your interest.
Yeah.
Well, I would also like to mention to say thank you to Mr. Leslie as well, because in the beginning there wasn't really any STEM fields at McKinley Tech at all, but through the work and effort that Mr. Leslie did, he was able to create the engineering STEM field and then leading on to all the other ones at McKinley Tech. So we would just like to take the time and say thank you to Mr. Leslie as well.
Definitely.
Yeah. Thank you.
Have a good day.
Have a good day.